Hello and welcome to a few minutes of real world math. My name is Johnny Wu and I am your host for today. This is a sample podcast for ETEC 565, an open educational resource on podcasting. The purpose of this podcast is to discuss real-world examples where we can apply math. Since everyone is a first-time listener, we like to start off the show by posing a real-world question and use different kinds of math to really understand the answer to that question. Today we'd like to ask, how much water is in the oceans on planet Earth? Now, it would be easy to simply pull out your mobile device to Google the answer to this question and see what pops up, which when we do that, it will tell you that there's roughly 326 million cubic miles or 524 million cubic kilometers of water. Now, that is important information, but it doesn't really tell you how much water there is deep down in your brain. It just sounds like a lot of water. So let's answer this in a way we can visualize and understand it deep down inside. For understanding liquid, let's talk about containers. So the container my brain can visualize right away is a 2-liter Coke bottle full of water. I see 2-liter Coke bottles all the time in stores. I love to drink Coke at a barbecue on a hot summer day. So now the question becomes, how many of these 2-liter bottles do I need to fill up most of the water in the ocean? Now I say most because I believe that it's pretty much impossible to get all of the water in the ocean, but let's just go for the majority. So the next step is to find out how many total liters there are in the ocean. Well, each cubic kilometer has 1,000 liters. Each million cubic kilometers has 1 billion liters of water. So I know that there are 524 million of these cubic kilometers in the ocean, which means there are 524 billion liters of water, which means I will need 262 billion 2-liter Coke bottles to fill up most of the water in the ocean. Wow, that sounds like a lot of bottles. But if you're like me, you are probably starting to have a hard time imagining 262 billion 2-liter Coke bottles. So let's do some more math to try to envision it. Let's take these Coke bottles and stack them vertically. Will it reach the moon? To find this, we need to use kilometers as our unit. If you Google the question, how tall is a 2-liter Coke bottle? Google will tell you that it is 336 millimeters. All right, it's more conversion time. So, if each bottle is 336 millimeters, then each bottle is 33.6 centimeters, or 0.336 meters per bottle, or 0.000336 kilometers per bottle. You multiply that by 262 billion bottles, and that gives us a total of 88,032,000 kilometers when you stack these bottles vertically. Now that's a crazy number of kilometers. To put it into perspective, the distance from the Earth to the moon is 332,400 kilometers. So if you were to make stacks of those 2-liter Coke bottles filled with the ocean's water, you could make 229 stacks of bottles from the Earth to the moon. Using that same 88,032,000 kilometers that these bottles make, if I were to stack these bottles horizontally, we could use the country of Canada to start to envision it. Since Canada is only 8,030 kilometers across, if we were to divide that 88,032,000 by that cross-country distance, these bottles could span across Canada 10,963 times. So to summarize, in answering the question, roughly how much water is there on planet Earth in the oceans? Well, it would take 262 billion 2-liter Coke bottles to soak up most of that water. If you were to stack these bottles from the Earth to the moon, you could make 229 of those stacks. If you were to stack them across Canada, you could take 10,963 trips across Canada on these bottles. Wow, that is a lot of water. I hope you enjoyed a few minutes of Real World Math, Episode 1. If you like what you heard, please like, share, favorite, and subscribe on iTunes. You can also follow me on Twitter at rwmguy84 and give feedback or just tell us what you thought of the show. You can also ask your real-world math questions on Twitter, and if your question works, we could answer it in a future episode. Check back weekly for new episodes. Until next time, keep solving that math in the world around you. Thanks for listening.
The podcast you just heard was published with Anchor. Got something you want to say to the creator of this show? Send them a voice message using the Anchor app, free for iOS and Android.